In 1931, a journalist asked Nikola Tesla what he thought of Albert Einstein's theory of relativity. Tesla's response was blunt: "A magnificent mathematical garb which fascinates, dazzles, and makes people blind to the underlying errors. The theory is like a beggar clothed in purple whom ignorant people take for a king." Einstein, for his part, rarely mentioned Tesla publicly. When pressed, he acknowledged Tesla's contributions to electrical engineering, but dismissed his theoretical physics as outdated. For decades, their names have been pitted against each other: the practical inventor versus the theoretical genius, the man who lit up the world versus the man who reimagined space and time. But was there really a rivalry between Nikola Tesla and Albert Einstein? Did they actually clash, or is this another legend we have constructed because we need our heroes to have enemies? This is the story of two men who changed physics in completely different ways, and why we have to stop forcing them into a fight they never really had. To understand whether Tesla and Einstein were rivals, we first need to understand how different their worlds were. Nikola Tesla was born in 1856 in what is now Croatia. He came of age during the height of the electrical revolution, when the practical applications of electromagnetism were transforming industry and daily life. Tesla was trained as an engineer. His genius was in visualization, experimentation, and building things that worked. He saw physics as a tool for creating tangible technology: motors, generators, wireless communication systems. Albert Einstein was born in 1879 in Germany, a full generation later. He came of age during a different revolution, the crisis in theoretical physics that would lead to quantum mechanics and relativity. Einstein was trained as a theoretical physicist. His genius was in thought experiments, mathematical elegance, and reconceptualizing the foundations of reality. He saw physics as a quest to understand the fundamental structure of space, time, and matter. Tesla's peak creative years were the 1880s and 1890s. By 1900, he had already invented the alternating current motor, the Tesla coil, and laid the groundwork for wireless communication. He was famous, wealthy, and celebrated as the man who would bring humanity into a new electrical age. Einstein's breakthrough came in 1905, his miracle year, when he published papers on the photoelectric effect, Brownian motion, special relativity, and mass energy equivalence. He was 26 years old, working as a patent clerk, unknown to most of the world. By the 1920s, he was the most famous scientist alive, so their careers overlapped in time, but not in focus. Tesla was an experimentalist working on applied electromagnetic technology. Einstein was a theorist working on the fundamental laws of the universe. They operated in different intellectual ecosystems. Tesla did not hide his disdain for Einstein's relativity theory. He made his views public on multiple occasions, especially in his later years when he felt increasingly sidelined by the scientific establishment. In a 1932 interview, Tesla called relativity a mass of error and deceptive ideas violently opposed to the teachings of great men of science of the past and even to common sense. He believed that Einstein's rejection of the ether, the hypothetical medium through which light and electromagnetic waves were thought to travel, was a fundamental mistake. For Tesla, the ether was essential. His entire understanding of wireless energy transmission depended on the idea that space was not empty, but filled with an invisible substance that could carry electromagnetic waves. He believed that by understanding and manipulating the ether, humanity could transmit power wirelessly across vast distances, tap into limitless energy, and fundamentally reshape civilization. Einstein's special relativity, published in 1905, did away with the ether entirely. Einstein showed that light did not need a medium to travel through. Space and time themselves were relative, dependent on the observer's frame of reference. The ether, according to relativity, was unnecessary. To Tesla, this was not just wrong, it was intellectually dangerous. He saw relativity as abstract mathematical philosophy disconnected from physical reality. He accused Einstein of hiding behind equations rather than building devices that proved his ideas worked in the real world. Tesla also believed that relativity had led physics down the wrong path. He thought the obsession with abstract theory had distracted scientists from practical problems like wireless energy and advanced propulsion. In his view, Einstein represented the triumph of theory over experimentation, of abstraction over application. But here is the important point. Tesla's criticism was not personal. He did not attack Einstein as a person. He attacked the ideas. And in doing so, he revealed his own bias. The bias of an experimentalist who believed that only what you could build and measure was truly real. Einstein, for his part, said very little about Tesla. There is no record of Einstein writing extensively about Tesla's work, no letters debating his ideas, no public speeches praising or condemning him. When Einstein did acknowledge Tesla, it was in passing, and usually in the context of electrical engineering rather than theoretical physics. In one documented instance, Einstein was asked about Tesla's contributions. He acknowledged that Tesla had done important work in alternating current systems and electrical engineering, but he made it clear that Tesla's theoretical ideas about the ether and the nature of electromagnetism were not in line with modern physics. Einstein did not engage with Tesla's criticisms of relativity. To Einstein, Tesla was working with an outdated model of physics. The ether theory had been tested and abandoned. The Michelson-Morley experiment of 1887 had shown that light did not require a medium. Relativity was built on experimental evidence, not just mathematical abstraction. From Einstein's perspective, Tesla was a brilliant engineer who had revolutionized electrical technology, but who did not understand the deeper theoretical shifts happening in physics. Tesla's genius lay in invention, not in foundational theory. So while Tesla was vocal in his opposition to Einstein, Einstein was largely silent. And that silence is telling. It suggests that Einstein did not see Tesla as a rival in the realm of theoretical physics. Tesla was simply working on different problems, in a different tradition, with different tools. The core of the supposed rivalry is the ether debate. This is where their views most clearly diverged, and it is worth understanding what was actually at stake. In the 19th century, physicists believed that light and electromagnetic waves needed a medium to travel through, just as sound waves travel through air. They called this medium the luminiferous ether. It was thought to fill all of space, providing the fabric through which waves propagated. But the ether had problems. No one could detect it. It had to be incredibly rigid to support the high speed of light, yet also completely invisible and intangible. Experiments kept failing to find evidence of its existence. The Michelson-Morley experiment in 1887 was the most famous. It attempted to detect Earth's motion through the ether by measuring differences in the speed of light in different directions. The result was null. Light traveled at the same speed regardless of direction, suggesting the ether did not exist, or at least did not behave as expected. Einstein's special relativity in 1905 provided an elegant solution. There is no ether. Space and time are not separate, fixed backgrounds. They are interwoven into a four-dimensional space-time that bends, stretches, and interacts with matter and energy. Light does not need a medium. It is a fundamental feature of space-time itself. Tesla rejected this. He believed the ether was real, and that its existence was essential for understanding electromagnetic phenomena. He thought that future experiments would eventually detect it, and that relativity would be revealed as a temporary mathematical convenience rather than a true description of reality. History sided with Einstein. Subsequent experiments, on time dilation, relativistic mass increase, and the bending of light by gravity, confirmed the predictions of relativity. The ether was abandoned by mainstream physics, but Tesla never accepted this. Until the end of his life, he maintained that the ether existed and that Einstein was wrong. One of the most common questions people ask is, did Tesla and Einstein ever meet in person? The answer is, probably not, or if they did, there is no record of it. Tesla lived and worked in New York for most of his career. Einstein visited the United States multiple times, especially after fleeing Nazi Germany in 1933 and settling at Princeton. But there is no documentation of the two ever sitting down together, debating in person, or even attending the same events. They moved in overlapping but distinct circles. Tesla was famous in engineering and popular science circles. Einstein was celebrated in academic physics and among intellectuals. Their paths could have crossed at events like scientific conferences or public lectures, but no credible account exists of such a meeting. If they had met, it would have been awkward. Tesla was dismissive of theoretical physicists. Einstein was polite but firm in his belief that experimental evidence supported relativity. A conversation between them would likely have been cordial on the surface, but fundamentally unproductive, since they were arguing from entirely different premises. The absence of a meeting is significant. It suggests that the rivalry we talk about today is more of a constructed narrative than a lived reality. They did not spend their time thinking about each other. They were focused on their own work. So if they barely interacted and operated in different fields, why do people insist on framing them as rivals? The answer lies in how we tell stories about science. We love binaries. We love conflict. Inventor versus theorist. Practical versus abstract. Old guard versus new wave. These narratives are simple, dramatic, and easy to understand. In the case of Tesla and Einstein, the contrast is almost too perfect. Tesla represents hands-on experimentation, the lone inventor in his lab, the man who built the modern electrical grid. Einstein represents pure thought, the theoretical genius scribbling equations, the man who reimagined the cosmos without leaving his desk. It is tempting to see them as opposites, and in popular culture, especially on the internet, that contrast has been amplified into a rivalry. Memes pit them against each other. Articles ask, who was the greater genius? Forums debate whether Tesla's practical contributions outweigh Einstein's theoretical breakthroughs. But this framing is misleading. Science does not progress through winner-takes-all battles between individuals. It progresses through the cumulative work of many people, each contributing in different ways. Tesla advanced electrical engineering. Einstein advanced theoretical physics. Both were necessary. Both were brilliant. Forcing them into a rivalry diminishes both. It reduces Tesla to an anti-intellectual crank who refused to accept progress. It reduces Einstein to an ivory tower academic who ignored practical applications. Neither characterization is fair. While mainstream physics sided with Einstein on relativity, it is worth acknowledging where Tesla's instincts were not entirely wrong. First, Tesla was correct that electromagnetic fields fill space. He just used the wrong word, ether. What we now call the electromagnetic field is a real, physical entity that permeates all of space. It is not a substance in the classical sense, but it is also not nothing. Quantum field theory describes it as a field of potential energy that can produce real, measurable effects. In a sense, Tesla was groping toward the concept of fields as fundamental, even if he used outdated terminology. Second, Tesla was right to emphasize the importance of experimental verification. While he went too far in dismissing theory, his insistence that ideas must be tested and built into working devices was a valuable corrective to purely speculative physics. Modern physics benefits from both theory and experiment working together. Third, Tesla's vision of wireless energy transmission, while not achieved in the way he imagined, foreshadowed real technologies we use today. Wireless charging, radio wave power transmission, and even discussions of space-based solar power all echo Tesla's dream of energy transmitted through the air. So, while Tesla was wrong about the ether and wrong to dismiss relativity, his broader instincts, that space is not empty, that energy can be transmitted wirelessly, and that practical applications should guide research, were not entirely misguided. Einstein's correctness about relativity is now beyond serious dispute. Every prediction of special and general relativity has been confirmed by experiment. Time dilation, the slowing of time at high speeds, has been measured in particle accelerators and verified in GPS satellites. Mass energy equivalence, expressed in the equation E equals mc squared, is the basis of nuclear power and nuclear weapons. The bending of light by gravity was observed during a solar eclipse in 1919, making Einstein world-famous overnight. But Einstein's contribution went beyond just being right about relativity. He changed the way physicists think about the universe. Before Einstein, space and time were thought to be absolute, fixed backdrops on which events unfolded. After Einstein, they became dynamic entities that interact with matter and energy. This shift opened the door to modern cosmology, black hole physics, and our understanding of the Big Bang. Without relativity, we could not explain the expansion of the universe, the behavior of extreme gravity, or the nature of space-time itself. Einstein also represented a new approach to physics, starting from fundamental principles and deriving predictions through rigorous mathematics. This method has proven extraordinarily powerful. Quantum mechanics, the standard model of particle physics, and string theory all follow in Einstein's footsteps, building theoretical frameworks and then testing them experimentally. So Einstein was not just correct about relativity. He was correct about how to do physics at the deepest level. The story of Tesla and Einstein teaches us several important lessons. First, genius comes in different forms. Tesla was a genius of visualization and invention. Einstein was a genius of abstraction and theory. Neither approach is superior. Both are necessary. Second, disagreement is not the same as rivalry. Tesla criticized relativity. Einstein largely ignored those criticisms. That is not a feud. It is simply two people working in different paradigms, with different values, who did not see eye to eye. Third, history is kinder to some contributions than others. Einstein's work became the foundation of modern physics. Tesla's work became the foundation of electrical infrastructure. But popular culture often portrays Tesla as a misunderstood visionary whose ideas were suppressed, while Einstein is treated as the ultimate authority. The truth is more nuanced. Both made lasting contributions. Both were limited by the knowledge and tools of their time. Fourth, we should be careful about constructing false dichotomies. The internet loves to frame science as a battle between camps: Tesla versus Edison, Tesla versus Einstein, experimentalists versus theorists. But science works best when different approaches complement each other. Finally, respecting both means not forcing them into competition. Tesla does not need to be elevated by tearing down Einstein. Einstein does not need to be defended by dismissing Tesla. They can both be giants without one needing to defeat the other. So, was there a rivalry between Nikola Tesla and Albert Einstein? Not really. There was disagreement, yes. Tesla opposed relativity and clung to the ether. Einstein moved physics forward by abandoning the ether and embracing space-time. But disagreement over scientific ideas is not the same as personal rivalry. They operated in different worlds. Tesla was an inventor focused on practical applications. Einstein was a theorist focused on fundamental principles. They barely interacted. They did not spend their lives thinking about each other. The rivalry is something we created, long after both men were gone, because we wanted a simple story. Inventor versus theorist. Old versus new. Practical versus abstract. But the real story is more interesting. Two men, each brilliant in their own way, each contributing to human knowledge from different angles, each limited and elevated by their unique perspectives. Tesla gave us the electrical grid that powers modern civilization. Einstein gave us the conceptual framework that explains the universe. We do not have to choose between them. We can honor both. And we should stop pretending they were enemies just because it makes for a better story. Because the truth, that they were different kinds of genius working on different problems, is actually more profound than any rivalry could ever be. If you want to explore more myths and truths about Tesla, the next episode investigates his friendship with Mark Twain and what it reveals about Tesla's human side. Subscribe. Because understanding Tesla means understanding the difference between legend and reality, and sometimes reality is even better.